This chapter is all about using chemical reactions to do some actual calculations. So what we're going to learn to do in this chapter is to figure out if you start with a certain number of grams of compound, how much product can you get from that? So first we need to talk about conversion factors, which are fractions that are equal to 1, and they're used to change one unit into another. So throughout this whole chapter, we're going to really focus on units and how you can cancel units and get them to convert. For example, if I wanted to know how many seconds are in 2 years, you would use conversion factors to get from years to seconds. And remember, the fraction is equal to 1 when the numerator equals the denominator. So that means when the top of the fraction is equal to the bottom. For example, 2 over 2 means that that fraction is going to equal to 1. The fancy way to talk about this problem-solving method is dimensional analysis. Once you set up these problems, it's going to end up looking like a fence. So I call it the fence post method. So if you hear me say you need to set up a fence post, that's really what I'm talking about. Dimensional analysis is just the fancy way to say it. So it's a problem-solving method using conversion factors to cancel unwanted units. So to set these up, the first few you can probably do your own way or even in your head or on your calculator, but I want you to set it up the way that I'm showing you, because once we get to chemical reactions, this way is going to help you organize all your numbers and get everything lined up so that your units cancel. So you always start with what you're given in the top left corner of your fence, and you won't know how many fence posts to draw, so you can just draw one and then just keep drawing them as you need them. So you start with what you're given. The first thing you're always going to do is take this unit, not the number, but the unit that you're given, and you're going to pull it down diagonal, because we want to cancel the dollar sign. And in order to cancel a unit, you need to have that unit on the top of the fraction and on the bottom of the fraction. So I'm going to set up a conversion factor, and basically this is a fraction that's equal to 1, because 4/4 is the same amount of money as $1. So I essentially have the same amount on the top of the fraction as the bottom, so this fraction is equal to 1. So when I multiply 1 by $25, I'm not changing the value of the $25, I'm just changing the unit. Since we have dollar sign on the top and on the bottom, those two are going to cancel, and we'd be left with quarters. But we don't want quarters, we want nickels. So the next thing you're going to do is take this unit, not the number 4, but just the unit quarters, and pull it down diagonal, because we want it to cancel. And then on top, you put what you're looking for. So we would put nickels on top, quarters on the bottom, and then set up your conversion factor. So 1/4 is equal to 5 nickels. Now we can check that all our units cancel. So we have dollars on the top and the bottom, we have quarters on the top and on the bottom, and we're left with nickels. So now we're ready to calculate it. And all you have to do is multiply across the top and divide by everything on the bottom. So it would be 25 times 4 times 5 divided by 1 divided by 1. So it looks like this. Obviously you don't need to type in 1 in your calculator, but this is just to show you how to set it up. And you get 500 nickels. Let's try another one. This time we're going to go from 180 days, a school year, to seconds. So the first thing is you always start with what you're given in the top left corner. Then you can take this unit, the unit of days, and pull it down diagonal. So now days is going to go down here, and think of a conversion factor you can do with days. So I don't know how many seconds are in a day, but I know off the top of my head that there's 24 hours in one day. So this sets up our conversion factor. If we stopped here, days would cancel because they're on the top and the bottom, and we'd be left with hours. But the question asked for seconds, so we're going to continue. Now you're going to take this unit, the hours, and pull it down diagonal. Not the number, just the unit. The next thing I know about an hour is that it can go to minutes. So I put pulled hour down and then plug in your numbers. There's 60 minutes are equal to 1 hour. Now hours cancels and we're left with minutes. But we want to go to seconds, so we're going to do it one more time. So take the unit of minutes and pull it down diagonal, and you're going to put seconds on top. Plug in your numbers, so 60 seconds are equal to 1 minute. It's just a coincidence that these two problems have 1s on the bottom of all these. It's not always going to be like that. It just happens to be for these two problems. So now days cancels days, hours cancels hours, and minutes cancels minutes. So once we do the math, we'll be left with seconds. So you're going to multiply across the top, so 180 times 24 times 60 times 60, and then divide by the bottom. So divided by 1, divided by 1, divided by 1. And you end up with a huge number because obviously it's a lot of seconds in 180 days. These are some common conversion factors to know, and it looks a little confusing. Let me explain what this box is showing you. Base unit is not used in science, it's just saying in general what you're measuring. So for example, if you're measuring length, your base unit would be meter. If you're measuring volume, your base unit would be liter, L-I-T-E-R, and if you're measuring mass, your base unit would be grams. So you won't ever see base written in a problem, you'll see either meters, liters, or grams. If you were doing meters, then 1 meter is equal to 100 centimeters. So you just fill in this blank with whichever choice you had over here. So if you were doing 1 gram, it's equal to 100 centigrams. Down here, if you were doing 1 gram, it's equal to 1,000 milligrams, or 1 meter is equal to 1,000 millimeters. So whichever of these 3 choices you chose for your base unit, that's what would fill in the blank over here. So if we want to go from centimeters to kilometers, the first thing again is to start with what you're given. Then you can automatically take that unit, the centimeters, and pull it down diagonal. And the only conversion factor we have up here is that first one. So I know that 100 centimeters is equal to 1 meter. Our base unit here is meter. So first set up your units. Notice that centimeters needs to cancel, so I have that on the bottom. And then plug in your numbers. If you wait on your numbers, you won't flip them around. A lot of people mess up their numbers because they try to plug them in first. So 100 centimeters is equal to 1 meter. So now centimeters cancels and we're left with meters. But we want to go to kilometers. So now we're going to take that m and pull it down diagonal. On top of the fraction we're going to put kilometers. And this is our conversion factor right here. So 1 kilometer is equal to 1,000 meters. So make sure you put the 1 with the km and the 1,000 with the meters. Check to see that your units cancel. So centimeters cancels centimeters, meters cancels meters, and we're left with kilometers. So this time we're going to do 125 times 1 divided by 100 divided by 1,000. And you should get 0.00125. One more of these type just to show you how to do a fraction. If you have a fraction for a unit, you want to split it up on your fence. So 15 meters per second is essentially saying you're going 15 meters in 1 second. So you're going to break that apart. And we need to convert both of these because notice that the top of this is different and the bottom. So I'm going to start with meters and convert that first. So I take the meters and pull it down diagonal and put km on top. And if you go back to that box to look at the conversions, you can see that there's 1,000 meters for every 1 kilometer. So now kilometers is on top, which is what we wanted. So now we just need to get hours on the bottom. Since seconds is on the bottom over here, we need to pull it to the top of the fraction so that it'll cancel. And then on the bottom, I'm going to go to minutes first. So notice that now I have seconds on the top and seconds on the bottom over here, so those will cancel, and we're left with minutes on the bottom. But we want to have hours, so we need to do it again. So pull the minutes up to the top, put your hours on the bottom, and then plug in your numbers. And then meters cancels meters, seconds cancels seconds, and minutes cancels minutes. And notice that the 2 units we're left with are km on the top and hours on the bottom, which is what we wanted in this fraction. So you just have to do your math. So 15 times 60 divided by 1,000. You can stop here if you get a chance and try a few on worksheet number 1. All the answers are on the worksheet for you. So if you look at the end of the question, you'll see it says answer. Make sure you check your answers as you go, and make sure you set these fence posts up so that I can look at your work if you didn't quite get it right. The next thing we're going to talk about has to do with the word mole. So in chemistry, we want to talk about how much stuff we have. We can either do that by count, mass, volume, or words like mole. So mole is kind of like the word dozen, where it just means a whole bunch of things. It's the SI unit for measuring an amount of a substance. And this conversion factor is in your reference packet, so you don't need to memorize it. It says that 1 mole is equal to a whole lot of particles, 6.02 times 10 to the 23rd. You won't see the word particles in a question, you'll see a word that means a lot of particles. So in the question, you'll either see the word atom, molecule, or formula unit. Be careful when you abbreviate molecule. I want you to abbreviate it MLCL so you don't confuse it with mole. And if I ever say Avogadro's number, this is the number that I'm talking about. A representative particle is the smallest unit that still has the characteristics of that substance. And I'll show you what I mean on the next slide. So if you just have an element like copper, the smallest unit you can go to is an atom, unless it's one of the diatomic ones. So if it's a Hofbrinkel one like hydrogen, you do need that too, and that would be a molecule. If it's a covalent compound, it'll be a molecule, and if it's an ionic compound, it'll be a formula unit. So just to walk through a few of these, it's just like we did with the metric system. So start with what you're given in the top left corner. You have 4 moles of calcium. Then you're going to take moles and pull it down diagonal, and we're turning it into atoms, so that goes on top. Whenever you use Avogadro's number, you will never put this big 6 number with the word mole. So if you have mole down here, you need to put Avogadro's number with atoms. Whenever you use this conversion, 1 needs to go with mole, and the big number will go with atoms. So it's just 4 times 6.02 times 10 to the 23rd. Let's go backwards. If we start with 5 times 10 to the 18th atoms, this time atoms needs to be pulled down, and moles will be on top because that's what we're looking for. Notice that I plugged in 1 with the mole and Avogadro's number with atoms. Be careful when you type this in your calculator and make sure you put parentheses around Avogadro's number. Alright, another one, 9.2 moles of F2. So you're going to pull your moles down, molecules goes on top. Make sure you plug in the 1 with the mole and Avogadro's number with molecules. So 9.2 times 6.02 times 10 to the 23rd. I'm going a little fast because this video only lets me record 15 minutes. So feel free to pause it if you need to write some stuff down. This one's a little bit different because notice that I asked you for atoms of fluorine and I only gave you something that's not an atom. So if I ask you for atoms and I give you a compound that's bigger than that, you're going to have to do an extra step. Let me set it up and I'll walk you through it. So we started with moles and we pulled moles down. And the problem is you can only use Avogadro's number for the smallest unit that you're given. So if you look at what you're given, F2, the smallest unit of this is not an atom. It's a molecule because it has more than 1 atom in the compound. So when we use Avogadro's number, this is important, you can only use it for the smallest unit that you're given. Then, if I want to know the atoms, I look at this molecule and I say for every 1 F2 molecule, I have 2 atoms of fluorine. This extra step you only have to do if I ask you for atoms and I give you something that's bigger than 1 atom. So you don't always have to do this. It's just if I ask you for atoms and give you something bigger than 1 atom. So 9.2 times 6.02 times 10 to the 23rd, and then times 2 atoms. And let's do one more of those. This time we're starting with moles of C2H4, and I asked you for total atoms. So again, if I ask you for atoms, a red flag needs to go off in your head and you need to say, do I need to do that extra step? In this case, yes, because this is a big compound. So when we use Avogadro's number, it will not turn it into atoms, it'll turn it into molecules, because this is not an atom, this is a molecule. Once we have molecules, we can say that for every 1 molecule of C2H4, there's a total of 6 atoms, because we have 2 carbons and 4 hydrogens. So that gives us 1.22 times 10 to the 25th. The mole conversions are on your second page of your worksheets, so I want you to try those. What I would do is go through those numbers first and look at the ones that ask you for atoms. So for example, I know that the last question on page 2 asks you for atoms, but it gives you a big compound. So in that case, you would have to do this extra step. So I would go through and figure out when you have to do that extra step first and circle those numbers, and then go back and start over and see if you can do these. Most of the questions will only be 2 steps, not 3. And make sure you check your answers. They should be on worksheet 2 as well. And that is all for today.